Hi, hello everyone. So today we're going to have a look at the cosine rule. So the cosine rule is a kind of a rule that's used for a particular scenario. So I'm going to show you the two scenarios in which you would use the cosine rule. And if it's not one of these two scenarios, I would always encourage people just to use the sine rule or something else. Okay, so the three scenarios are where you want to find an angle and you know the three sides. So as you can see here, you can't use the sine rule because you don't have two pairs. You don't know either of those angles, so you can't pair up to create your fractions for your sine rule. So this would be a scenario where you'd have to use the cosine rule. A second scenario, and probably the one that's most obvious, is where you know two sides and you know the angle in between, and you're looking for the third side. So again here we can't use the sine rule because we don't have a complete pair. We don't have an angle with a side opposite it that we can use to create our fractions. So these would be the two scenarios we would use. So first of all, I'm going to show you how the sine rule is derived because you need to know it. But you can skip this bit for the next 3 minutes and move on to examples of the cosine rule if you haven't learned the following kind of stuff about trigonometric identities. Okay, so I'm going to use my xy axis here to help me. And what I'm going to do is I'm going to plot 3 points. Okay, I'm going to put a point there, I'm going to point a point there, I'm going to put a point there. And I'm going to join these 3 points into a triangle. And I'm going to label these 3 sides. Okay, I'm going to call this side A, this side here B, and this side here C. And I'm going to label this angle as capital A because it's always opposite. Okay, so the cosine rule is a really cool rule. Okay, so what I'm going to do is I'm going to show you something really cool. I am going to draw a circle where the center is going to be at A and the radius is going to be B. So there we have a circle drawn. Okay, so I am going to show you the coordinates of these points. This point here has a coordinate of 0, 0. This coordinate has a distance of C away, so it has a coordinate of C0. And this one, now, this is the important one, and it's a very important one. This, from the unit circle, we can get this coordinate in terms of sine and cosine. So as you remember from the unit circle video, any point along a unit circle will have its x and y coordinate. They can be transposed into cosine and sine coordinates, but they're done it based on the radius of the circle that's created. Now, if it's a radius of 1, it's just cos and sine. But in this case, it's a radius of b. So the coordinate of this will be b cosine A, comma, b sine A. So if b was 1, that would be just cos A sine A. If b was 2, it would be 2 cos A sine A, but it's just b. So now I have 3 coordinates. And what we're going to do is we're going to find the length of this coordinate. We're going to find the length of A. So we're going to find the length of A. Now, how we're going to do it is using coordinate geometry. So we know the length of A should be the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so that's what we're going to do. So let's see how we can do it. Let's get an x1, y1 and an x2, y2 from this. So here's our x1, y1. Let's put this one down. B cosine A and b sine A. Okay, that's x1 and y1. And let's call this one x2 and y2. And that's c and 0. So let's slot these in here and see what happens. So we have the absolute value of A, that's the distance of A, is equal to the square root of A squared, sorry, x2 minus x1 plus y2, sorry, that's x2, sorry, that's c, sorry, and then y2 minus y1. So that looks really kind of scary, but don't worry, it's not going to be scary. So the first thing I'm going to do is I'm going to get rid of the square root by squaring both sides. 0 minus b sine a to be squared. Now, I'm going to have to square out these brackets, so let's do it. Square the left, square the right, so minus b by the cosine of a, all to be squared. Well, that's just take the minus b bit and square it, that's just b squared, and then that's just cos squared a, and then multiply them together and double it, minus 2bc cosine a. Okay, sorry, that's a bit tight. And then this one's a lot easier. And when you square a negative, it becomes a positive, plus b squared sine squared a. Okay, so now that I've done that, let's see what I've looked like. And that's still equal to a squared. So let's have a look and see what I've got. Okay, so what I can see here is I've got a 2bc cos a. So I'll just write that all down there again. A squared is equal to c squared minus 2bc cosine of a plus b squared cosine of a plus b squared sine squared of a. Now, what I'm noticing there is that there's a b squared in both of these. So let's see, can we factorize that out? And I can indeed. So now this is where, if you haven't done trigonometric identities, you won't know this, but if you look on your log tables on page 13, the cos squared of a plus the sine squared of a is just 1. So that's actually a squared is equal to c squared minus 2bc cosine of a plus b squared times 1. And let's just multiply that out. So that's a squared is equal to, well, that's b squared times 1 is b squared. That's plus c squared minus 2bc cosine of a. And that is the derivation of it. Okay, now how do we use this crazy derivation? So even if you didn't know any of this, you can still use this formula just by knowing the pattern. So I'm going to write down the pattern and I'm going to show you. Okay, so here's an example. Let's say I want to find that side, and I know that that's 10, that's 8, and that's 50 degrees. So how do I use the cosine rule to do this one? Okay, well listen, let's write down the rule. A squared is equal to b squared plus c squared minus 2bc cosine of a. So all I need to do is identify what my a, b's and c's are here. Okay, well this is a, that's it there. B and C can be either of those, just pick one. So let's just say I'm going to say B is going to be 10, C is going to be 8, and capital A, and this is the important one, the angle has to be the side, opposite the side you're looking for, and vice versa. So that's going to be 50 degrees. So let's pop it all in. A squared is equal to B squared plus C squared minus 2 times B by C by the cos of 50 degrees, which means that A is just going to be equal to the square root of all this. You can just skip this line of work if you know how to square root while you're doing this line. So let's do this. So square root 10 squared plus 8 squared minus 2 times 10 by 8 by the cos of 50. 7.82. Okay, so that's how you do it. There's nothing more tricky than that. That's how you find the missing side. Now, finding the missing angle. This is where it gets a little bit more tricky than that. So I'm going to show you an example of how to find the missing angle. So let's say I have 7, 6.8, 9, and I'm missing a. So again, I'm going to write out my formula. A squared is equal to b squared plus c squared minus 2bc cos of a. I'm going to write in everything I know. So I know a because it's the side opposite what I'm looking for. So a is 9. B, let's just make it 6.8. C, let's make it 7. The angle is what I'm looking for. So let's pop it all into the formula. So a squared is equal to b squared plus c squared minus 2 times b by c by the cos of a. Now, let's just strategize, because you could spend ages doing this sum, but let's realize what's going to happen. This is on the opposite side of the equal sign to all of this. So the first thing that's going to happen is these two things are going to be subtracted from this. And then all of this is going to be divided by that answer. And then we're going to get the inverse of that. So A is going to be equal to, so watch, 9 squared. We're going to subtract these two. So watch, I'm just going to subtract these two. So I'm using brackets. That gives me an answer. And then I'm going to divide that answer by all of this. And then look, I haven't written anything down. And then I'm going to get the cos inverse of that answer. And I get 81.39. Or sorry, 81.4. Okay, so there you go. So that is my strategy for doing this way. You can do it in stages if you want. You could just do 9 squared subtract 6.8 squared. That answer subtract 7 squared. That answer divided by minus 2. That answer divided by 6.8. That answer divided by 7. And that answer get the inverse cos of it. But why, when you can just do it all in one go?